I came across this theory a long time ago in the 1990s and I applied it to mental health problems, to psychological therapy. Once I started publishing work on this, I got contacted by people who were using it. And one of those, Dr. Rupert Young, he was using it to build robots and robotic systems. So I got in touch with him, and over the years we discussed how we could work together to show how this theory could help robots function better, to balance, to move around, to focus on things, etc. By the time it came to this research study, I was fairly confident that it was going to work because Rupert had ran and created many of these robots already. He just hadn't had a chance to test them using the kind of conditions that we set up here in Manchester. So I was quietly confident, and then when the data came through, it was particularly exciting. The data showed that when we replaced the existing engineering software in this robot with the new perceptual control theory software, it worked at least as well. It balanced better, it was able to remain stable, even when it was prompted or prodded by disturbances in a way that the original software wasn't able to do. We could also get it to move from one location to the other and keep that stability while it was doing it. I think it's really important that we have theories that we use in psychology, in mental health, that are informed by wider science and that have an application to behaviour beyond the therapy room, beyond humans, even beyond living organisms. And so that's why perceptual control theory is particularly useful, because it sets out principles that work across all those domains, principles around control and balance, for example. And so for me, constructing these robots actually then shows us that the basic principles behind the theory that we use very widely work. Plus, I would say that as we're using more and more digital solutions and people are interacting more and more with technology, again, I think it's important that we have a scientific theory that can be easily usable across these range of domains. So we've been discussing what the next step is, and our plan is going to be to build the software with its own learning algorithm, which is also based on the original theory. This will mean that the robot, rather than being tuned by the kind of experimenter, it can tune itself. It can work out how to get the right weights and balances in the software to make it balance. And then if we confront it with a bigger challenge, maybe change its weight, change the surface, then it can actually learn and tune itself rather than relying on the experimenter to do it. So the reason why we built a fairly simple robot that balances on these two wheels as an inverted pendulum is that it's a very common test example that's used within robotics and engineering. It's used because it actually takes quite a lot of computation normally to provide that level of balance. It's like learning to ride a unicycle, essentially. And it's assumed that we need those balancing skills if we're to walk on two legs. And so it's a basic building block of then going on to build a walking robot and understand the more sophisticated forms of locomotion and skills that people and other animals have. One of the advantages of our system is it was a lot simpler than the software that was in there originally. But that software that was there is typical. It used computations to work out the body weight, the directions, the movements of the robot itself, and to calculate the behaviour that was going to be outputted. That was the original system. It needed to have all that knowledge about its own body. On the other hand, the perceptual control theory robot did not need to use any of that knowledge to keep balanced. So it's a much simpler approach. This is because it's only interested in its sensory inputs and controlling those, and it will just change its behaviour dynamically to keep it experiencing that sense of balance, if you like. So we think that's a major advantage if we want to improve robotic systems, but also if we want to make our interventions in psychology more simple and effective.